Okay guys, here I am writing out the answer key. I'm going to do it in real time. I hope it works out okay. We've got some function g of x and we've got to evaluate what is happening here. The minus will reflect it over the x-axis. It'll flip it from north to south, and the plus 3 will shift it 3 units to the left. Apologies, I'm trying to keep out of the camera's line of sight while I write here. This one will simply reflect it over the x-axis and move it up 2. So reflect over, y-axis, it's the horizontal, it's east-west flip axis, and then shift up 2. Alright, given this function and f of x and g of x, which if any of the above are even or odd? Okay, so you've got to decide. Well, let's start with this one because that's easier. G of x is a parabola. Simple parabola is an even function. So I'm going to write even next to this one, and then I'm going to say because f of minus x equals f of positive x. Okay, that's the mathematical definition. And I could maybe say by example, oops, I'm saying g, that's a g, sorry. G of minus 10 equals 100, and that equals g of 10. Alright, you don't have to do a lot more than to show me that you understand the math behind it. This one, you can pop it on your calculator or whatever, but if you look at that, look at it under a microscope, it's doing something like this, where these are 2 and negative 2 for zeros, and then it goes through the origin. This is an odd function. Not odd as in strange, but odd is in the sense that f of minus x is equal to negative f of x. Okay? So again, for example, f of negative 3 equals, in this case, if I plug that in, negative 3, that's 27, and then plus 12, that's going to be negative 27, plus 12 is negative 15, and then if I plug in 3, that gives me positive 27, minus 12 gives me 15, and you can see then that if I do the minus sign out here, that equals minus 15. That maybe isn't clear, but you can write it out maybe in words a little bit better. Alright. If I go down to these composite functions, f of g of 2, I just simply find what is g of 2. G of 2 is 4, so you can write that. G of 2 equals 4. And then f of 4 is going to be my f of g of 2, and f of 4 is going to be 64 minus 16, so that's 48. And g of f of negative 1, so f of negative 1, do that first, and f of negative 1 is going to be negative 3 plus, negative 1 plus 4 is 3, and so then g of 3 is 9. Okay, so I can double underline or circle or whatever I should do to show that that is the answer. F of g of x is simply going to be taking the g of x and putting it in for every x in f of x. So f of g of x is going to be something to the third minus 4 times that something, and into those parentheses goes my g of x, x squared and x squared. And so that's simply going to be x to the 6th, my rule of exponents, minus 4x squared. Okay, so that's that answer. G of x, well, that's just going to be g of x, and that's going to be something squared, and inside that something goes x squared. And so I'm just going to get x to the 4th. Okay? Fairly straightforward. These last ones here in this page express the function as the composition of two functions. Well, we know that we have a function, the sine of x. All right. So really it's what is in place of the x. Well, that's x squared. So my two functions then are going to be like g of x and then f of x is going to be x squared. All right. So my composition is to put this in place of the x. So that's going to be g of f of x. Okay, because I'm going to take the x and g and replace that with f. And so if I write it like that, it'll be g of f of x, with these being function 1 and function 2. All right. Find the inverse of this function. All right, well that's an exponential with e as the base. So I just need to know my steps. I can write y equals this. I'm going to save time, and then I'm going to switch the x and the y. So x equals e raised to the y minus 3 and then plus 2. And now I just need to solve and get y by itself. To do that, I'm going to subtract 2 from both sides. And then I'm going to write that up there. And I get, I'm going to start switching places. So e to the y minus 3 exponent is equal to x minus 2. I need to get that variable out of the exponent. We invented logarithms to do that. I've given you base e, which is pretty easy, so I take the ln of both sides, and out comes that exponent. So then the ln and the e cancel because it's actually base e. So any log base a of a or log base e of e goes poof into 1 and disappears. So I get y minus 3 equals the ln of x minus 2. And then all I need to do is add 3 to both sides. So y equals ln of x minus 2 and then plus 3. And if I were smarter, I would have put in a question about domain and range. You should think about that maybe if I had asked it, but I didn't, so I won't do it now. Find the domain and range of this function though. This is one out of the book. It was problem number 8. I think I stole it. If you think about what is the domain of the ln of x, it's helpful to think visually. It's always the ln of x is going to be a function that's like this. It goes to that vertical axis when x equals 0. You cannot take the log of a negative number. You can't even take the log of 0. So right away, this domain is restricted to be numbers that are greater than 0. But these are values of the ln of x that are negative. So we can't plug them into the second log. Well, when does this happen? This happens any points that are less than or equal to 1 will give you a domain that you can't have. So my domain is going to be all real numbers, and x must be greater than 1. X must be greater than 1. It cannot be equal to 1, because if I take the ln of 1, I get 0, and I can't take the ln of 0. All right? The range then, numbers that come out will be from this function will be all real numbers, because if it gets really, really close to 0, I'll get function values that are very, very steeply negative. So all real numbers for my range coming out. You can put that in your calculator and look at it if you don't believe me. All right, second page.